Hello everyone. In this video we will talk about the preparation as well as the standardization of potassium permanganate solution of 0.1 normal strength. Okay, so let us firstly talk about the requirements. So the chemicals which we need are oxalic acid, potassium permanganate. The glassware which we need is burette, pipette, conical flask, volumetric flask, funnel, beaker and a glass rod, and the equipment which we need is analytical balance. Okay, so these are the same things which we have been talking about in all the preparations as well as the standardizations. Now let us begin with the main part, which is the preparation of potassium permanganate of 0.1 normal strength. Okay, so what do we have to do? We have to weigh accurately about 3.2 grams of potassium permanganate and then dissolved in 1000 ml of distilled water. Okay, so let us now understand why exactly we have to take 3.2 grams of potassium permanganate. So if you have watched my previous videos also, there also I have explained that whenever we have to prepare normal solutions, what do? We see the equivalent weight, and equivalent weight is equal to the molecular weight upon the n factor. Okay, so we have to see the equivalent weight, and equivalent weight is equals to the molecular weight. Equivalent weight is equals to molecular weight upon n factor. Okay, so molecular weight of potassium permanganate we can calculate, and now let us talk about the n factor. N factor is either the number of H positive or the OH negative ions, or also if in terms of redox reactions we talk about, then it is the amount of electrons which are being gained or lost in the reaction. Okay, so we will see a redox reaction of potassium permanganate, and then we can calculate the n factor for it, and after that we will calculate its equivalent weight, and then finally we will know how to prepare its normal solution. Okay, so I have already written the equation for it, which is important over here. So this is the our permanganate ion. It is undergoing redox reaction, and in this reaction what is happening, 5 electrons are being involved. Okay, so this is the n factor of potassium permanganate. The n factor is 5. Okay, so I said that molecular mass of potassium permanganate I have already calculated. It is 158.034 gram per mole, and we know that equivalent weight is equals to the molecular weight upon n factor. Therefore when we divide the molecular weight by 5, so the value which we will get is 31.6 gram, which can approximately be equal to 32 gram. Okay, this is the equivalent weight of potassium permanganate. This means that when we will dissolve 32 grams of potassium permanganate in 1000 ml of solution, the solution which we will get will be having strength 0.1 normal. Okay, so this is how we have prepared our 0.1 normal solution of potassium permanganate. This equation is very important to write down over here, this one. Okay, now let us begin with the next part, which is the standardization of potassium permanganate. So the solution which we have prepared just now, we will standardize that in this step. Okay, so what we have to do, we have to this experiment is based on the redox titrations, in which strength of an oxidizing agent is estimated by titrating it with a reducing agent and vice versa. Okay, so potassium permanganate act as a strong oxidizing agent in acidic medium that oxidizes oxalic acid in carbon dioxide. Endpoint can be detected by appearance of permanent pink color. Potassium permanganate will act as a self indicator. Okay, so this is just the general theory part of this standardization. Now let us see the reaction. What is happening, that potassium permanganate reacts with oxalic acid in acidic medium, and carbon dioxide is being evolved, and the endpoint is detected by the appearance of permanent pink color, and potassium permanganate is acting as a self indicator for determining the endpoint. Okay, so now let us do the methodology so of this titration. So what we have to do, we have to take 20 ml of 0.1 normal oxalic acid in conical flask. Okay, and then we will add in the conical flask 5 ml of sulfuric acid in order to make the medium acidic, and then we will fill the burette with potassium permanganate solution, which we have already prepared, of 0.1 normal strength. Okay, and then we will start the titration with potassium permanganate solution until the endpoint is reached. Okay, so this is the our titration process, and then we will use this formula to calculate the actual strength of our potassium permanganate solution. So N1V1 is equals to N2V2. So here N1 is the normality of oxalic acid solution which we have taken in the conical flask. V2, here N1 we have done. So V1 is the volume of oxalic acid used in ml. N2 is the normality of potassium permanganate solution, and V2 is the volume of potassium permanganate solution which will be used. Okay, so all of these values, V1, uh, V1, N1 as well as V2. Okay, these all we can calculate easily by performing the titration, and after that we will put all of these values in this equation, and then we will finally get the final strength of our potassium permanganate. Okay, so this was all which was in the preparation as well as the standardizations of potassium permanganate. So with this video we have completed the preparations and the standardizations of all our compounds in our pharmaceutical analysis. So in the next video we will continue further with our first module. So if you like the video, please subscribe. Thank you.